So now we're going to continue on with section 7.2 questions. We are going to remove question 24 and question 25. So you don't have to worry about those two questions on the review. We're going to continue with question number 26. The p-value for a hypothesis test is given. So here the p-value is given as 0.033. And do you reject or fail to reject the null when the level of significance? So the level of significance is 0.01. You always compare the p-value to the left of the alpha or the level of significance. So, and I also recommend, since you have 3 decimal places for the p-value in this particular question, you should also make the other decimal points, in this case the level of significance, add another 0 so that you're comparing 3 decimal places. So 3 decimal places with 3 decimal places, 0 equals 0. So these two values are the same. Then you have a 3 for the p-value, then you have a 1 here, or in general, 33 is more than 10. So the p-value is greater than the level of significance. So if the p-value is larger than the level of significance, we will conclude that there is not sufficient evidence or information to decide no, this one, and it's not reject the null. You will answer reject the null when the p-value is less than the alpha. So the correct answer here is C. You will fail to reject the null hypothesis because the p-value is larger than the level of significance. So the correct answer here is option C. So the next one, we're also provided with a p-value. So the p-value here is 0.007. So again, the p-value always to the left. Alpha here is 0.01. The p-value has 3 decimal places. The level of significance should also have 3 decimal places. So we're comparing 7 with a 10 here. So the p-value is less than the alpha. Therefore, you reject the null hypothesis. So when the p is low, the null gotta go. That's it for that one. Question number 28. Fine. So here we are not provided with a p-value. You are having to find it. So find the p-value for the hypothesis test with the standardized test statistics, the z-value. Decide whether to reject the null for the level of significance of alpha. So they're giving us the z-score, so we don't have to find it, and they tell us that this is a right-tail test. So with those 2 items, I'm able to see that if this is a right-tail test, it will be somewhere in here. This is 0.52, and again, this is a right-tail test. And the level of significance, alpha, is 0.05. So once we find the p-value, and what is the p-value? The p-value is going to be the area to the right of 0.52. So remember that the z-score tables that we have, they give you the area to the left. So we're going to find the area to the right, the area to the left. So I'm going to find 0.52, this area here. And in order to find the p-value, I'm going to subtract that answer from 1. So 0.52, if you look at the z-score tables, the 2 is the 3rd column, so positive 0.52. 0.52, it will be the 3rd column. It is 0.6985 in this table that I have here. 0.52 is 0.6985. So minus 0.6985. So you will subtract this value from 1, and the difference will be the value for your p-value. Again, it's because your table only gives you the area to the left. So 1 minus the area to the left will give me the value of the area to the right. And we always round it to no more than 4 decimal places. So now we're going to compare this p-value. So the p-value is 3015, and the alpha or level of significance is 0.05. So add two zeros in order to match the number of decimal places. But here the p-value is greater than the level of significance. So we found the p-value 0.3015, 0.3015. So since the p-value is greater than the alpha, the outcome will be that you're going to fail to reject the null hypothesis because the p-value is larger. So the right answer will be option A. So number 29, find the p-value. So it's the area under the curve, and they're giving you the z-score and they're giving you the alpha. So we draw a picture and it says that it's a left tail test. So I'm going to be to the left and it's negative 1.83. Since you're being asked to find the area to the left and the table gives you the area to the left, you do not have to subtract from 1. So you will go to the table and find negative 1.83, and that is the fourth column, and in here I have 0.0336. So that p-value 0.0336, and we're going to compare that 0.0336, the p-value. We're going to compare with a level of significance that is 0.05, match the decimal places. So here I'm comparing 336 with basically 50. So therefore 0.0, the 3 is less than the 5, so this is going to be less than. So the p-value that we found 0.0336, this will be the only answer, and it will be reject the null because the p is low, so we reject the null. So the correct answer here will be letter D for question number 29. Next question. Find the p-value for the hypothesis test with the standardized test statistics Z, and this one is a two-tailed test. So this one we tend to sometimes miss this question, so it is a two-tailed test. So we highly recommend that you draw the normal curve, two-tailed test. And the p-value is going to be the sum of the area in your tails. So this is going to give you half of the p-value, and the other one will give you the other half of the p-value. So, and the z-score is 1.95, so this is the area to the right. And then the area to the left will be negative 1.95. When you have a two-tailed test, one is positive, one is negative. So the easiest one to find is the area to the left, and that way we just multiply them by 2 because they're going to be the same area with the same z-score. So you're going to go look in your z-score table at negative 1.95, negative 1.9 and 5, you go over. I'm getting 0.0256. So the p-value 0.0256. 0.0256, so it will be the sum of those two numbers, 0.0256 plus 0.0256, or you could have just multiplied them by 2. Okay, that's another thing that you can do. So, and I think that's how it is explained in my stat lab, the software in the interpretation. So this is going to be 0.0256 plus 0.0256. I'm getting 0.0512. So 0.0512, this is going to be your p-value, the sum of the area in the tails. So you're going to compare that with the alpha. The alpha is equal to 0.05. Since this one has 4 decimal places, I match this one to 4 decimal places. So this is 0 is the same, 5 is the same, but then here I have a 12 and here this is a 0, so this is greater than. And since the p-value is greater than the level of confidence, you're going to fail to reject. And the correct answer for question number 30, it will be A, 0.0512, and you fail to reject the null. Next question. So in section 7.2, organize the papers. So in section 7.2, question number 31, find the critical value and rejection regions for the type of z-test with level of significance alpha. So if it is a right-tailed test, you have a right-tailed test, it's right here, level of significance is 0.01, and find the critical value and the region for the type of z-score. So right-tailed test, alpha is 0.01, so we have different z-scores. In this question number 31, I was just making sure that I was looking at the right table here. So the level of significance is 0.01. And this one you were told that this was a right-tailed test. So your critical value is 2.33. So 2.33, and it is a right-tailed test. 2.33, a right-tailed test. So that makes letter D the right answer. So that value was given to you. If it was not given to you, you're going to find the area to the left, and that would have been in the z-score table 0.9900, but there, that one is not exact, so the closest one it was 0.9901, so that will give you 2.3 and then 0.03 here for your z-score. So that's how you will come up with 2.33 as your z-score, the one that you see in the correct answer and in your normal curve. That's your z-score. Okay, so that one, the correct answer will be letter D. Question number 32. On question number 32, it says that it is a two-tailed test and the alpha is 0.01. So it is the same alpha. So you're going to look at your table, and on the table you have 0.01, but this is for a left-tailed test, a right-tailed test. So since you're looking for a two-tailed test, it will be plus or minus 2.575. So, and so far the only one that has that is this one. So your z-scores, if we draw a normal curve, this is going to be negative 2.575. This one is positive 2.575. So remember, the p-value will be inside of those regions. And it's going to be to the right of 2.575, so that will be greater. To the left of this one, so that's why you see less than the negative, greater than the positive, and this is the one that is equal to, one positive, one negative. So that's why the right answer here was letter B. On the next one, question number 33, find the critical value and rejection region for the type of z-test with a level of confidence alpha. So this one is your alpha is 0.05. So that is your level of confidence is 0.05. And this one, it says that it is a left-tailed test. I apologize. It's not this one. That's a right-tailed test. It's a left-tailed test. So inside this area, we're going to have 0.05. That's what we know so far. So in order to find, you're going to look at the table here. If we're going to find it by hand, we do have the level of significance. This level of significance of 0.05 is in there. So, and again, this is a left-tailed test, so this is going to be a negative 1.645. So they give you the z-score here, 1.645. So this one is the one that is between two values. Again, ignore this part. So it's going to be negative 1.645, and the area is to the left. So that's why the correct answer is letter D. So again, I didn't use the table, but if you were going to, you're going to look for the one that is the closest to 0.0500. And again, there are two values that are the closest. So 1.6 and then 0.045 is how you got the z-score value or the critical value. So on the next question, number 34. We're going to continue this in another video because I'm getting close to the 15 minutes.